Yo, what's up guys, in the last video I showed you guys how I'm going to code the bishop and the rook, which I think are the hardest pieces to code. Today we're going to look at the queen, the king, the pawn, and the knight. Now we don't even need to worry about the queen because it's basically just a mix of the bishop paths and the rook paths. So I can just run both the bishop and the rook function at the same time to see if a queen move is legal. Now let's start with the king and the knight. These pieces are very simple because they only have 8 possible squares that they can move to. The king can only move one square in any direction. And I was trying to figure out how can I simplify this code? How can I code the king's movement without just hard coding in all the possibilities? So because the king can only move one square in any direction, the change in the x and the y coordinate is either going to be 0 or 1 square. So what I can do is I can set up an if statement where for both the x and the y, if the change is less than or equal to 1, then it is a legal king move. And then we just check this square. So if we decide that the king can move to this square, we check, is there a piece on it? If there is a piece, is it the opposite color? If it is the opposite color, the king can take it. If it is the same color, the king can't take it. And that's really all for the king. Now, the knight is fairly simple, a little more complex, because it moves in this L-shaped pattern. And this L is always the same. It's always 2 squares in one direction and 1 square in another. Now I thought, what if I were to take the change in the x and the y, ignore the negative sign, so find the absolute value, and add them? Wouldn't that always give me 3, 2 plus 1? That would work, but I had to find any other cases that would mess with this. And another thing that equals 3 is 3 plus 0. Now this is very easy to avoid. All I need to do is at the beginning check if the change in one of the coordinates is 0. And if the change in x is 0 or if the change in y is 0, then it's just not legal. It's not possible. So then now I can keep the rule where if the change in the x and the y value adds up to 3, then it's a legal knight move. And of course, I need to do the same logic that I did with the king for if there is a piece in the way. So if there's a piece on the square that's the same color, I can't take it. If there's a piece with the opposite color, then I can take it. Now the pawns are a little different because which direction they move depends on which color they are. So at the beginning, I get the pawn's color, and then depending on if it's white or black, it's going to be moving up or down. So then I can basically just use the same code for the black and the white pawns, just one is going to be going in the opposite direction of the other. Now, generally, pawns just move one forward. So if there's nothing in front of it, it's allowed to move forward. But a pawn can only take diagonally. And this is also fairly simple to code because the x-coordinate should only change by 1, so either adding 1 or subtracting 1. And then the y-coordinate should only be changing by 1 in the direction the pawn is moving. So either +1 or -1. And then finally, if a pawn has not been touched yet, it's actually allowed to move forward 2 spaces instead of just 1 space. Again, fairly simple, but now I need to check 2 squares. So I need to make sure that there's nothing in the square immediately ahead of it, and there's nothing in the square 2 squares ahead of it. Now, of course, the capturing rules still apply to the pawn, where if the piece is the same color, we can't take it, and if it is the opposite color, we can take it. So in this video, we talked about how to make the queen, the king, the knight, and the pawn, completing our set of chess pieces. Next video, I'll be talking about how I can take all of this code and connect it up to some sort of user interface. So stay tuned for that, and peace.